Start back. We're going to pick up with our group data. Now, as you go over that frequency distribution, I'm going to review a little bit about frequency distributions as we go over this group data a little bit, so that'll give you a little bit of that information together. But with group data, you generally have items that are occurring more than once. And so you create what's called a frequency table to organize that data in. And in this particular set of data, we don't have items that are consecutive, but when we organize our table, we do want to arrange it so that it goes from least to greatest. So as we look through our data, we have items that start at the smallest value at 10. And then in order, that would put us at 11.3. And then 12.4. 14. 18. And then 34.5. I think that's all of them. So group data with your central tendencies. In this case, our example is the list of bonuses for NFL players, and these numbers represent millions of dollars for our players. So we have a variety of amounts here of data to look at. And when we're doing group data, we would want to organize that data in a table first. And we're going to do mean first when we calculate, but we've got to get the data organized first. But I just want to take a moment for you to look at this formula for the mean. It is a little bit different from that formula that we looked at earlier, because you'll see this F thrown in there. That F is representing the frequency that the value occurs. And so we're going to multiply the frequency times the data value and then sum that up in order to help us find the mean. And so I'll show you how to use that formula in just a minute once we get our table finalized. Now, the purpose of the tally column is just to help us organize the data. And so I like to recommend for you to go through your data one at a time and put the tallies down. So I mark off the data as I put them into the tally mark to help be sure I know I've gotten all my data in my list. So I'm going to put 14 in and put a tally mark. Put 18 in and put a tally mark. 14 in is going to get another tally mark. 34.5 gets a tally mark. 11.3 and a tally mark. 10 gets a tally mark. 34.5 and a tally mark. 11.3 and a tally mark. 10 and a tally mark. 11.3 and a tally mark. 12.4 and a tally mark. 10 and a tally mark. 14 and a tally mark. 10 and a tally mark. And then 18 and a tally mark. And so I've been through all my data. And so by marking it off as I put the tally marks in, helps me keep track of whether I've covered all the items as I put the tallies down. And so if for a larger amount of data, that's certainly a very good technique to use to help you keep up with organizing your data. Now, my frequencies come from how many tallies do I have? So for the amount of 10 million, I have 4 for the frequency. For 11.3 million, that item occurred 3 times for bonuses. 12.4, only 1 person got that bonus. 14 million, 3 people got that bonus. 18 million, 2 people. And then we had 2 exceptional players who got the $34.5 million bonus. So that is just a quick little review of how you do a frequency table. And this is also called a frequency distribution. And so that is one of the things in lesson 2 that you do on your own, is how to create a frequency distribution. And so that's how you do it. And so we're doing that to get to the point to be able to calculate our mean for a grouped data. So a frequency distribution is a grouped data situation. So the next part is to calculate the mean for that set of data. So our sample mean is going to be multiplying the frequency times the data value. So that means we do 4 times 10 plus, so we're doing the frequency times the data value, and then the sigma means to add them all up. So 3 times 11.3 plus 1 times 12.4 plus 3 times 14 plus 2 times 18 plus 2 times 34.5. And all of that is divided by the total number of data values. So what I want to do is to add up my frequency column. 4 plus 3 is 7, plus 1 is 8, plus 3 is 11, plus 2 is 13, plus 2 makes 15 for my total number of data values. Of course, I could go up here and count my list as well. They should match up. And then to continue with my mean, when I do all this multiplication and adding, I should get 233.3 divided by 15, which comes out to be 15.57. I still use that rule for rounding. Since we had to the tenths place, I round to the hundredths place for my answer. So the average bonus salary was 15.57. And that was in millions of dollars for the bonus salary. Now, how do you compute the median when you have a grouped data? The median is still the middle number. So if there are 15 items, that means that's an odd number. So 15 divided by 2 is 7.5, or the 8th item is the middle. So 8 is not the median. What value goes in the 8th position? So 4 plus 3 is 7, plus 1 more is 8. So in the 8th position is 12.4 million. So 12.4 million is the median bonus. The mode. What occurred most often? There was one bonus salary that occurred more often, which was the 10. So we're looking for the highest frequency group. So we would say 10 million is the mode. And then for the mid-range, we would take the lowest salary amount, 10 million, plus the highest salary amount, 34.5, and divide it by 2. It doesn't matter that their frequencies have extra numbers. We only are looking at the data values. And so we get 44.5 divided by 2, or 22.5 million is the mid-range. Bonus salary. So that's how we would calculate each of those values, mean, median, mode, and mid-range, for a grouped set of data. So we have our group and those positions in the chart, and we calculated each of those from that chart. One of the things that confuses people is here what to do with the frequencies. The frequencies really only came into play when calculating the mean and when determining the mode. We did use the frequencies to help us find the median in terms of which item to select, but it all goes back and ties into what is the actual amount. So be careful with that. Another thing that I want to point out is with group data, also sometimes has classes that has ranges. So our classes in this case was the actual amount. The class was 10 million. The class was 12.4. The class was 18 million. Sometimes that is not the case. Sometimes the class is a data range. And when that is the case, then you want to use the midpoint for the data value. So in these particular ones, there was no question about what the data value was. But when you have a range, it is hard to determine what you use for the data value. So for example, if we have a class that ranges from 10.5 to 15.5, what do you use for the data range or the data value? The range is from 10.5 to 15.5. Well, that doesn't give us one value to use in the mean. We need one value. We need the midpoint to help us determine the value for that. So keep in mind that this is the lower limit or the lower boundary. This one is the upper limit or the upper boundary. And we want to find the midpoint. We're going to use those two values to find the midpoint. So we're going to take the lower limit plus the upper limit and divide by 2 to find that midpoint. So in this case, 10.5 plus 15.5 divided by 2 gives us 26 divided by 2, or 13. And that is the data value for the class with that range. So you do have to keep that in mind. Again, the group data and the class ranges, as you go over the unit lesson 2 with frequency distributions, it will go into this group data and the classes a little more detailed there. So it is important for you to go back and look at that particular section to look at finding the class value. So I did just want to touch on that for a moment to be sure that you knew what to do there. All right, next thing we want to do is to find a weighted average. Weighted averages can be used when you buy something that you buy in quantities for a particular amount. For instance, if you go to the hardware store and you buy a certain type of nails, they're priced at a particular quantity based on the weight of or the number of nails that you buy. Excuse me, the same thing's true about screws in that case. If you go to a bakery or a sweet shop and you buy one type of candy, it's at a certain price, and then you buy a different type of candy at a different price. You have to look at finding individual amounts times the weight and then combining together to find the overall price. So that is doing weighted means in order to do those calculations. These calculations are similar to a group data mean, but it is a little bit different. Although it is similar, there is a little bit of difference. So we certainly want to look at some examples to be sure you know how to do these particular kinds of problems. One of the most common things that you do with weighted means are GPAs. So that's the example that I'm going to do for you. So if you were calculating your GPAs, and you could do this for yourself, if you looked at your semester GPA, so you want to take both terms, the classes that you've taken for both terms, and let's say you've taken an English course that was 3 credits, and your grade that you earned in that class was an A, and you took a psych class that was 3 credits, and you earned a C in your psych class, and you took a biology class. Usually biology classes, science classes, have labs, so they have more credits, so it was a 4-credit class, and you earned a B. And you took a PE class this term, but it's rained so much you never want it to go. and that PE class was only 2 credits. And so because you didn't go, your attendance brought your grade down and you only got a D. So we're going to find what your GPA would be for the semester. One thing to keep in mind, each of these grades have some kind of scale that goes with it. Typically, not always, but typically an A is 4 points, a B is 3 points, a C is 2 points, a D is 1 point, and an F is 0 points. And we use that scale to replace the number. And so in order to compute the GPA, or the weighted mean, we would multiply the value of the grade times the credit. So the English with the A would be 4 times 3 plus the psych class, the value of the C was 2 times the credit. The biology, the value of the B was a 3 times the credit. And the PE class, the value of the D was 1 times the credit. And then we're going to take all of that and divide it by the total number of credits that you took. So 3, 6, and 4 is 10, and 2 is 12. A minimum of 12 credits to be a full-time student. And so we calculate the top, and we get 32 divided by 12, which gives us a GPA of 2.67. And that's how you calculate your GPA. And it's a process called a weighted mean in order to do that. Okay, we're moving on at this point to our next topic, which is measures of position. We probably will not have time to get through all of this. I may have to post the last part of this online. Measures of position, where Central Tendencies had us look at the middle of the data. The measures of position is going to give us a particular location in the data. The one that we're going to start with first is called percentiles. And just like it sounds, percents are related to 100. So it is going to separate our data into 100 parts. It doesn't matter whether you have less than 100 or more than 100, it still separates the data into 100 parts. If you're given a percentile rank, it indicates that the percent is below that value. For example, if I said that I was in the 70th percentile, what that interprets to is 70% below that value. So if I'm in the 70th percentile, 70% of the people are below me at that value. To find the percentile, we're going to take the number of values below the data value and add 0.5 to it and divide by the total number of values. And we're going to multiply that times 100. So here's our example. These are quiz scores. So we have someone who made an 18 out of 20, a 15 out of 20, a 12 out of 20, a 6 out of 20, an 8 out of 20, a 2 out of 20, a 3 out of 20, a 5 out of 20, a 20 out of 20, and a 10 out of 20. And we want to find the percentile for the score of 12. So just like with median, the first thing we do is we arrange the data least to greatest. So we have 2, 3, 5, 6, 8, 10, 12, 15, 18, and 20. Now for our formula, we need to know the number of values below our indicated value. So we want to know the percentile for 12. So we find 12. And we want to know the number of items below 12. So there are 6 items below 12. So we're going to do 6 plus 0.5. There is a total of 10 items in our data values. And we're going to multiply times 100. And so we get 6.5 divided by 10 times 100, which is 0.65 times 100, which is 65%. So 12 is at the 65% range. Now, suppose we want to go backwards. We're given the percentile rank, and we want to know what data value is at that particular rank. So that's the next part of knowing what to do. So we want to be able to find the value at a percentile rank. We use this little formula, C equals N times P over 100 to help us calculate that. Keep in mind that we're always going to round up. So using our same set of data, 2, 3, 5, 6, 8, 10, 12, 15, 18, and 20, we want to find which value is at the 25th percentile. Which quiz score is at the 25th percentile? So C equals the number of data items is 10 times the percentile, which was 25, divided by 100. And so we get 2.5. And since we need to round up, that makes 3. We round up to a whole number. Now what this means the third item is at the 25th percentile. So in our data list, 1, 2, 3 means 5 is the third item in the list. So the 25th percentile is a score of 5. All right, so that's percentiles. Next, we're moving on to quartiles. So again, similar to the prefix, percentiles being 100, quartiles means we're going to divide our data up into 4 parts. we use the symbols Q1, Q2, and Q3. We only have 3 quartiles, even though that's all it takes to get 4 parts. Special note, quartile 2 is the same as the median. It's the same value, it's found the same way, you determine it the same way. To find the quartiles, you're going to find the median first, which remember is the same as quartile 2, which divides your data into 2 equal parts. Then you're going to find the median of each half. So the lower half is quartile 1. And the upper half is quartile 3. Again, you always arrange that data from least to greatest first. You have to do that first, or it's not going to work out correctly. So here's our sample data. We have 15, 13, 6, 5, 12, 50, 18, and 14. So if we arrange them first, that will give us 5, 6, 12, 13, 14, 15, 18, I left this off the list, 22, and 50. All right, so what's the first thing that we do? The first thing that we do is to find the median. So just like we did before, we have an odd number of items on our list. So with an odd number of items, 9 items, 9 divided by 2 is 4.5. The 5th item is the middle. 1, 2, 3, 4, 5. So the 14 is the median. The median is the same thing as quartile 2. This is 50% of the data on the top half. This is 50% of the data on the bottom half. So we have to know that the median divides the data into two 50% parts. Next, we're going to take each half. Now, since this is the median, we're not going to use that value. So we're going to look at the lower half. Find the median for the lower half of the data. Well, that's an even set of numbers. So when I have an even set of numbers, I have to find the 2 in the middle, which is 6 and 12. And so I add them together. 6 plus 12 divided by 2 gives me 18 divided by 2, which is 9. So that represents quartile 1, which is 9 at that point. On the upper half, same thing, 4 items on the upper half. So the 2 in the middle are 18 and 12. I add them together, divide by 2. That's going to be 40 divided by 2, which is going to give me 20. And so that quartile is going to be quartile 3 at that position, which has the value of 20. Now, what I have to recognize is this is first quarter, second quarter, third quarter, fourth quarter. The quartiles are the parts that divide it, but the quarters are each component. Each component is 25% of the data. So there may be questions to interpret your data based on knowing quartiles. How much data is above quartile 2? 50%. How much data is below 9? 25%, because 9 is quartile 1 marker. So those are the types of questions that might be asked in reference to quartile information. And that's the things you need to know about quartiles. Now, we did not get to go over 5-number summary or box and whisker plots, and that will be, I will post on the website for you to look at. They are still part of the lesson that you should know and get some information about. So you want to be sure that you do take a look at the rest of those notes. But that is all the time that we have for today, and I don't want to keep you beyond the time we have. If you have additional questions, you want to be sure that you do see me next week about them. I will be posting some practice homework problems dealing with central tendencies and measures of position for you to work on over the weekend. I will post some practice quizzes so that you can get an idea of practicing types of questions that you'll see for those particular types of problems. Okay, we'll probably have a quiz on Monday on Brightspace. All right, but that'll give you Monday during the day to be able to come see me if you need some extra help. Okay? Does that kind of give you an idea what to expect for the weekend? Any questions there? All right. Have a good weekend.
You too.
All right. See ya.